This is Math Studies Lesson 4.4, and we're going to be graphing linear systems today. That's graphing two lines at one time and looking at where they meet. So there are three possibilities. Case 1 is when two lines meet at a single point. Case 2 is if the lines are parallel, they will never meet. And case 3 is when the lines are technically the same line. So they are always together, infinitely many solutions. So the first example, we're going to graph these two lines and then show where they meet. And I think I actually have a bad graph situation here because my first line says intercept is 6, slope is -1. So my intercept is 6, my graph only goes to 5. So my intercept is kind of up here, just kind of eyeball that. And then the slope is -1, so that means I'm going to go down 1 over 1. And I'm going to repeat that a couple times so I can get a good idea of where this line is. My second graph has an intercept of -6, and again that's kind of off my graph. And then a slope of +2. Remember, that means up 2 over 1. So I count up 2 over 1 a few times so I can get an idea of where this line falls. And then to tell where the lines meet, I'm going to give the ordered pair of the coordinates. They intersect right here, so that is over 1, 2, 3, 4. And up 1, 2. Okay, I'll repeat a couple more examples. The next one says y equals -x. Now I see no intercept here. That means the intercept is 0. This line starts at the origin. And then the slope is -1. That means down 1 over 1. And so we can draw that line. The next equation is y equals 2. This equation has no x. That means the slope is 0. So this is going to be a horizontal line. The intercept is 2. So slope of 0 means over 1 up 0. And then where they meet will be my solution. That is -2, +2. 2 to the left and 2 up. Letter C, my first equation has an intercept of 1 and then a slope of -1/3, so down 1 over 3. And I'm going to kind of go backwards a little bit to get a nice line. My next equation has an intercept of -3 and then a slope of -1/3. So I don't know if you noticed right away, I kind of do. Those lines have the same slope. And we should know right away that two lines of the same slope will be parallel. This is no solution. So most of the equations will be in intercept form, but if they're not in intercept form, we need to put them in intercept form so that we can graph them, so we can see the intercept, so we can see the slope. So I need to solve for y. I'm going to do that by bringing the x to the other side of the equation. If I subtract x from each side of the equation, the y remains on the left, and on the right I have 5 minus x. So I could graph this line now with an intercept of 5 and then a slope rise -1, run +1. And I'm going to kind of just do the same thing. I have -3x from each side, and I have a -y left, 6 minus 3x. I need to get rid of the negative in front of the y. Simplest way to do that is divide both sides by -1. Divide or times, kind of the same effect. The negatives will cross out. Y is -6 plus 3x. And the last one, we're going to bring the 3x over. These are not like terms, so the 15 and the 3 stay separate. And then when we divide by everything. So y equals negative 15 over 4 would be negative 3.75. That would act as my intercept. And then minus 3 divided by 4 is 0.75. That would be my slope. If you wanted to leave it in fraction form, it's actually better in fraction form because then you go down 3 over 4, down 3 over 4. Much easier than down 0.75 over 1, down 0.75 over 1. Anyways, I think that's it for the notes. Good luck on the exercises, and please let me know if you have any questions.